Welcome to qnawire.
Once again, welcome to a new problem that we are all too familiar with. So imagine you're at home and you want to go to your physics lab, which is a specific distance from your house. Um, so let's just call it 5 kilometers. And you have two options. So either you're gonna, um, it's kind of like a fitness program. So you're gonna run and you're going to run at a speed of um, your velocity would be 10 kilometers per hour if you're running. And then the same thing happens, it's exactly the same distance from your home to the physics lab, and you have the option of uh, walking instead of running. Okay, so if you're going to be walking, your velocity you're much slower, so your velocity is 3.0 kilometers per hour. So those are the two options you have. The power, so the velocity in running, I'm just going to call it V of R. And then the power in running, I'm going to call it P of R, P subscript R. And it's the amount of energy. Remember, power is defined as the amount of energy you're using. So power is time derivative of work, or what we call energy. So it's the rate of change of energy with respect to time. So the power when you're running is 700 watts, and then the power when you're walking is lower, 290 watts. Your velocity when you're walking is 3.0 kilometers. So we want to find, if you compare walking and running, which one are you going to expend the most energy? In general, power is given us energy with respect to time. So if we're computing the energy, you multiply both sides by t, and this is a specific formula for finding the energy. But we don't have the time, so we need to find the time for running. That's the total distance traveled divided by the speed. If you can recall from your algebra classes in high school, distance is times velocity, or time is distance over velocity. So the distance traveled is 5 kilometers, and the velocity when you're running is 10 kilometers per hour. So the time taken is half an hour when you're running. When you're walking, it's a little bit different. So the time taken when you're walking is still the total distance over the velocity when walking. Total distance doesn't change. From your home to the physics lab, it's 5 kilometers. And then you divide that by the velocity, which is 3.0 kilometers per hour, and you get 5 thirds hours. Now we have the time. We can rely on the energy equation that connects power and time. So when you're running, the energy expended would be the power when you're running times the time when you're running. So that gives you 700 watts times the time, which happens to be half an hour. But we have to change the hours to seconds because the power itself is in joules per second. So power, this watts is joules per second. So we have to change all the units to standard units, and these 2 hours will cancel out. And when you simplify the problem, you get 1 point. So this is the power expended when you're not the power expended, but the energy expended when you're running 1.26 times 10 to the 6 joules. You do the same thing for while you're walking. The energy is ET equals to the power when energy when you're walking equals to the power when you're walking times the time when you're walking. So this is the power is 290 watts times 5 over 3. You still have to change that to seconds, which is 3,600 seconds in every hour. And so it's going to give us a final energy when you're walking seems like it's higher. It's 1.74 times 10 to the 6 joules. So if you compare the energy you lose, or the amount of energy you burn when you're walking, it's higher at 1.74 times 10 to the 6 joules compared to the energy when you're running, which is 1.26 times 10 to the 6 joules. So hope you enjoyed the problem. It's an energy comparison for those of you who love exercises. You can see that you can actually burn a lot of calories while walking than running. Feel free to send any questions or comments, and have a wonderful day. Okay, thanks. Bye.